Hi everyone. Today we're going to be completing our notes on verifying trigonometric identities. As a reminder from the last notes, an identity is an equation that's valid for all values of the variable for which the expressions in the equation are defined. We looked at some identities, including a difference of squares and its factorization. We looked at the Pythagorean identity, sine squared plus cosine squared equals 1, in its different forms. To verify trigonometric identities, I want to start off with just some strategies or guidelines that we can follow. Um, as before, when simplifying, writing them in terms of sine and cosine would be really helpful to simplify them. Algebraically, if there's two terms and you only want one, we can add fractions. So finding that common denominator is going to reduce the number of terms that we have. Additionally, if we factor something out, that can often help us simplify or get it into a different or workable form. Multiplying by a clever form of 1 is always an effective strategy. So we looked at like multiplying by the conjugate, right, is a clever form of 1. Sometimes that can help us change the form of something that's going to help us get it into a workable form. And then, of course, do any obvious algebra such as distributing, squaring, multiplying polynomials. Okay. So try different techniques and see what gets it in that workable form. We want to get it as close, not as close. We want to get it exactly equal to the other side of the equation. For trigonometric terms, some things that we can do is look for familiar trigonometric expressions, such as 1 minus the sine squared, cosecant times secant, cosine times secant, or sine over cosine, right? These are different forms where this first one is equal to cosine squared. The second, these are reciprocals of one another, so this is just equal to 1, this product here. And then sine over cosine is just tangent. If they're squares of functions, you should already be thinking Pythagorean identities. And then we can also reduce the number of functions, transforming them to the ones that you want in the answer. Okay? Keep looking at the answer to make sure that you're headed in the right direction. Okay, so verifying identities. To show that one side of a trigonometric equation is equal to the other, use the reciprocal quotient in trigonometric identities. Remember, you can only simplify one side of the equation until it looks like the other side of the equation. So you can't move terms to the other side of the equation. Yes, these are equations and we want to keep them balanced, but we're trying to verify the identity. So if we perform any operations to both sides of the equation, we're changing this equation here, right? Be it like a scalar multiple of, like if I were to multiply this whole thing by 2, then it would then multiply the whole equation, right? We just want to manipulate one side so that it leads to the other, therefore verifying the equality. Okay, so for any of these problems, you want to just pick one side and try to get it to look like the other. In most instances, I'm going to choose the left-hand side, which is usually the side that looks more complex, because if I can simplify that, I'll usually end up with the right-hand side. Okay, so for number 1, here we have cosine t plus tangent t sine t, and we want to get it equal to secant of t. Okay, so I'm going to just try writing this in terms of sine and cosine. So we have the tangent is sine t over cosine t, and then we have times the sine of t. Okay, and that should be equal to the secant of t. All right, so now I'm going to multiply those signs together, and I get cosine t plus the sine squared of t over cosine t. Okay, I want to get a common denominator, so I'm going to multiply this first term here by cosine t over cosine t. So I'm going to get cosine squared t over cosine t. And I'm going to add that to the sine t over cosine t. And I almost forgot, let's bring down secant t. Okay, now that we have a common denominator, we have cosine squared plus sine squared. And in your head, you should be thinking Pythagorean identity. That's all over cosine t. So the Pythagorean identity here, cosine squared plus sine squared is equal to 1. And so that is over the cosine t, which by definition is the reciprocal function, the secant of t. So we have verified this identity. And notice that I haven't done anything to the left-hand side of this equation, to the right-hand side of this equation. We've just manipulated the left-hand side. Okay, let's try number 2. So here, I notice that we're multiplying two binomials here. Okay, So let's go ahead and multiply these out. So we have 1 times the secant. So we have secant of y. 1 times the negative tangent. So negative tangent of y. Sine times secant. So that's both positive. So that is, I'm just going to write sine y secant y. And we'll see what that is in a moment. And then we have sine times negative tangent. So minus sine y tangent y equals cosine y. All right, now let's write this in terms of sine and cosine. So secant is 1 over the cosine minus the tangent is sine over cosine plus we have sine y times the secant of y, which is 1 over the cosine, and then minus sine y, and that's times the tangent. So sine y over cosine y. Okay. All right, let's combine where we can. So we have, let's combine these two terms here. So we have 1 minus the sine of y over cosine y. Then we have plus, this would be, actually, you know what? I noticed these are all over cosine y. So we can actually just add all of these together. We have a common denominator. So we have 1 minus the sine, and then we have plus the sine, and then we have minus sine squared. Okay. That's kind of nice when it works out that way. We have that common denominator of cosine y. All right. So then this minus sine y and positive sine y cancel out, and we're just left with 1 minus the sine squared of y over the cosine of y. You can probably see where this is going. 1 minus the sine of y is a Pythagorean identity that's equal to the cosine squared of y over cosine. And then we can cancel out one of those cosines, and we're just left with cosine y equals cosine y. There we go. That one's verified. All right, let's go ahead and flip the page. All right, so for this one, I'm looking at this, and to me, the right-hand side looks a little bit more complex. I'm going to go ahead and simplify the right-hand side and try to get the left-hand side. So we have 2 tangent x secant x. Okay? And this is equal to, if I wanted a common denominator here, I'm going to multiply this left-hand term by 1 plus sine x over 1 plus sine x. And I'm going to multiply this right-hand term by 1 minus sine x over 1 minus sine x. So clever forms of 1 here. Okay? So what we have is we have 1 plus sine x, and then minus 1 minus sine x. Okay, don't forget those parentheses. And then this is equal to, I'm sorry, this is over 1 minus sine x times the quantity 1 plus sine x. Okay. So 2 tangent x secant x is equal to, we have 1 plus sine x minus 1 minus sine x. Let's distribute that negative. So we have 1 plus sine x, and then that's minus 1, and then plus sine x. Okay. In the denominator, we have a difference of squares here. So this is 1 minus the sine squared, which we know is equal to the cosine squared. So we have 2 tangent x secant x is equal to, let's start combining things. This 1 and minus 1 cancel, and we're just left with 2 sine x. Okay? And this is over the cosine squared. All right, we're just about there. If we split up this cosine squared into 2 cosines, so we can combine one of those cosines with the sine. So we get 2 tangent x secant x is equal to 2, and then this one of the sine and the cosine goes together, and we get tangent. And then we have one more cosine in the denominator, which is secant. So we verified this identity. Okay. Number 4. Let's do the left-hand side. Neither of these look particularly more challenging than the other, so let's just do the left-hand side. All right, so we have cosine x over 1 minus sine x. So I'm going to multiply this by a clever form of 1, the 1 plus sine x over 1 plus sine x. So we get 1 plus sine x times cosine x over the product of 1 minus sine x times 1 plus sine x, or the difference of squares. Okay? And we want this equal to secant of x plus tangent of x. Okay. So from here we have cosine x. I'm distributing this cosine x. Cosine x plus cosine sine all over cosine squared. All right. Secant x plus tangent x. And what I'm going to do here is I'm going to split this up into cosine x cosine x over cosine squared x. I'm splitting up this denominator plus cosine x sine x over cosine squared x. And that's equal to secant x tangent x. Okay. Now you can probably see where this is going. We're going to cancel out one of these. So we have 1 over the cosine, or secant x. And then plus, we're going to cancel out one of these again, and we left with sine over cosine, which is tangent x. Okay. So this has been verified. All right, let's get some practice. All right, so let's verify this identity by simplifying the left-hand side. I'm going to write it in terms of sine and cosine. So we have 1 over the sine over sine x over cosine x plus the cotangent cosine x over sine x. And we want this to be equal to cosine x. Okay. Let's combine like terms. Find a common denominator, combining terms in the denominator. So we have 1 over the sine all over. We'd multiply the left-hand term by sine over sine. We'd multiply the right-hand term by cosine over cosine. So we would get sine squared x plus cosine squared x all over sine cosine, or sine x cosine x. Okay. We have that this Pythagorean identity. So we have 1 over sine x, and then that sine squared plus cosine squared is equal to 1 over sine x cosine x. And this is all equal to cosine x. All right, I'm going to bring it up here. So dividing by a fraction is the same as multiplying by the reciprocal. So 1 over sine is equal to sine x cosine x over 1. I'm sorry, that's times. So times. And that should be equal to cosine x. And it is, right? We cancel out factors of sine in both the numerator and denominator. We get cosine x is equal to cosine x. So this has been verified. All right. Number 2, we're going to distribute. So FOIL, or first, outer, inner, last. We're going to multiply every term by every term. We have the difference of squares, 1 minus the cosine squared of beta, is equal to 1 over the cosecant squared of beta. All right, well, this here is a Pythagorean identity. We get sine squared of beta is equal to 1 over cosecant of beta, cosecant squared. And then if we take the reciprocal of the sine, that is 1 over the cosecant squared of beta, which verifies the identity. Okay. Number 3. All right, so for this one, I noticed that we have 1 minus cosine squared and 1 plus cotangent squared. And we want this equal to 1. Well, I noticed that that 1 minus cosine squared is just sine squared. And I noticed that 1 plus cotangent squared is cosecant squared. Okay, if I were to multiply these out, I'm going to write these in terms of sine and cosine. So we have sine squared times 1 over sine squared. And just like that, these cancel out. Both the signs, we get 1 over 1, or 1. This verifies the identity. Okay, number 4. We have secant t minus cosine t all over secant t, and we want this equal to sine squared of t. All right, so let's go ahead and write this in terms of sine and cosine. So we have 1 over the cosine of t minus cosine of t all over 1 over cosine of t. Okay. Oops, and the variable is t. Okay. So let's find a common denominator. I'm going to multiply this cosine of t times cosine of t over cosine of t. So we get 1 minus the cosine squared of t all over cosine of t. And that's all over 1 over cosine of t. Okay? And we want this, again, equal to sine squared. I noticed that 1 minus cosine of t is the sine squared of t, and that's over cosine of t. And then dividing by this fraction is the same as multiplying by the reciprocal. I'm doing 2 steps here at once. Okay? When multiplying, we have a factor of cosine t canceling out, and we're just left with sine squared of t is equal to sine squared of t. And that verifies the identity. All right, go ahead and flip the page. Number 5. Let's go ahead and multiply this out. So we have cosine times secant. Well, that's reciprocals of one another. So that's equal to 1. And then minus cosine times cosine is cosine squared of x. And again, this is a Pythagorean identity. Sine squared equals sine squared. That one's quick and easy. Number 6, let's simplify the right-hand side. So we have cosine squared of x is equal to, writing this in terms of sine and cosine, we have 1 over the sine, and then we have cosine. And then in the denominator, we have sine x over cosine x, and then plus cosine x over sine x. Okay? So we have cosine squared x is equal to cosine over sine. And then we have finding a common denominator of sine x cosine x, we get sine squared x plus cosine squared x all over sine x cosine x. Okay, and I noticed the Pythagorean identity, sine x plus sine squared plus cosine squared. So we have cosine squared x equals cosine over sine, and that's all over 1 over sine x cosine x. All right, dividing by a fraction is the same as multiplying by its reciprocal. So we have cosine x over sine x times sine x cosine x over the 1. A factor of sine x cancels out, and we're just left with cosine squared x. And that verifies the identity. Okay, we got 2 more for us today. So we have number 7. We want cosecant squared. Let's go ahead and multiply this out. So cosine times secant, again, is an identity. Plus, we have cosine squared, cosine squared x, and then cosecant squared x. Okay. Well, one thing I notice here is that we have, well, let's write this in terms of sine and cosine. So we have 1 plus cosine squared x, and then 1 over sine squared equals to the cosecant squared. All right. And then we have cosine squared over sine squared is equal to the cotangent squared. And then I notice that we have a Pythagorean identity. This is the cosecant squared of x. Okay, so that verifies that identity. Let's do one more. So let's do number 8. We have tangent n plus cotangent n quantity squared. Let's go ahead and simplify that left-hand side. So we have, this is squared. So we have tangent squared of n, and then plus 2 tangent and cotangent n, and then plus cotangent squared of n. And then we have equals the secant squared plus cosecant squared. Okay. Well, I noticed that tangent cotangent is equal to 1, right? Those are reciprocals of one another. So we have tangent squared n plus 2 plus the cotangent squared n equals secant squared of n, I forgot an n up there, n plus cosecant squared of n. Okay, I'm going to do something a little bit clever here. I'm going to take this 2 and I'm going to split it up 1 and 1. So we have 1 plus the tangent squared of n plus 1 plus the cotangent squared of n. Okay. And you might notice 1 plus tangent and 1 plus cotangent gives us our Pythagorean identities secant squared n plus cosecant squared n. And that's, of course, equal to secant squared n plus cosecant squared n. All right. So this has been our notes on verifying identities. In summary, we want to use those properties for simplifying. So look for those reciprocal properties, those quotient properties, those Pythagorean identities. See if you can factor, combine terms, so finding common denominators, things like that. And we want to simplify just one side of the equation. We want it to be equal to the other side. So we have to verify the identity by just simplifying one side. We cannot perform operations to both sides of the equation. Okay? All right, so these have been our notes. We hope you have a great day. Goodbye, everyone.